Assalamualaikum and a very good day to all. I'm going to explain to you the work done and energy. So let's start. Okay, so the things that you need to understand when it comes to the work done, work is basically the force what we accomplish after we put some force on that object, and that object move through a distance. Okay, so when you push or pull or you do something on the object, you give some force to it, and the object itself move through a distance, then we are going to have work. Okay, so the things that you need to understand is when it comes to work done, the formula going to be work equals to force times distance. Okay, work equals to force times distance. But the things that you need to understand here, when it comes to the work done, you need to be extra careful, which means that you need to find the force that is basically parallel to the displacement. Okay, so your work can be happen or work can be occur if you have a something that parallel with the displacement. So now your displacement here are going to be your reference point. Okay, so that is mean by reference point. Reference point, it means that for the theta, which means that you can actually see from here the formula for here, work done going to be F d cos theta. The reason why it's become cos theta is because when you have one object and then you pull the object with some force that basically have an angle over there, so what happened is you are going to resolve this force. Okay, so when you resolve this force, you are going to get F sine theta, and another one you're going to get F cos theta. So like I mentioned before, for the work done to be happen or to be occur, you need to have force that is basically parallel to the displacement. So the only force that here that are going to be parallel is going to be F cos theta, and that's the reason why you are going to have the F d cos theta. So the theta here going to be the angle between D and the force that you choose. Okay, so example, if you have like something that on the inclined plane, example, okay, I put it something that on the inclined plane like this. Okay, and you have something like this. Okay, definitely you are going to resolve the force. Okay, you are going to resolve the force, so it means that they are going to have Fn here, you are going to have mg here, and this mg are going to be divided into mg cos theta, and this one going to be mg sin theta. Okay, so example, if this object, okay, if the object move with the distance is basically like this. Okay, like I mentioned before, you need to make sure that your D as your reference, so the force, the theta here are going to be between D and your F. Okay, so here example, if the question state please find the work done for each forces. Okay, so here your D going to be the reference point, and example, if I want to find the work done by normal force, then it's going to be 0 joule. Why is going to be a 0 joule? Because you can see that your D here and your Fn here, so the angle going to be 90 degrees. So when it comes to you put it inside the formula, you are going to get Fd cos 90 degree, and cos 90 degree means 0. That's why you're going to get 0 joule. Means that the normal force over there doesn't do any work. You can how about mg cos theta? So the mg cos theta is basically the same thing. So F equals to F here going to be changed by the mg's cos theta, because this is force. Okay, and then here D, and then you have another cos here which is going to be 90 degree. Please take note and don't be confused. The cos here, the angle here are going to be the angle between the theta, between the F and D, force and displacement, and the angle that is mentioned here is going to be the angle of, yes, very good, it's going to be the angle of inclined plane. Okay, so it's going to be like this, and this is your force. Okay, so this one also produce 0 joule. Okay, and how about another one? Okay, another one, you can see that we have mg sin theta over there, this one, and you can see that the D is in the same direction as the mg sin theta, which means that what is the angle between them is going to be, sorry, is going to be W equals to mg sine theta. Here theta, please take note, is going to be the inclined plane theta. Okay, and then multiply by d, and then the cos here going to be 0 degree. Okay, very good, because the d and the mg sine theta in the same direction, therefore it's going to be 0 degree. So it's going to produce a positive energy. Okay, and that's how you use the formula for the work done. And please take note, it need to be parallel to each other. Okay, and then you need to understand that the work done always be scalar. So means that the negative in the work done doesn't mean it's moving to the left. It means that decrease of energy. Okay, negative means decrease of energy, and the positive over there, it means increase of energy. Okay, so example, if you have something that, okay, example, if you have like one object and then you pull in this direction, okay, and then you have the frictional force which is acting in the opposite direction. Okay, so what happened is, first thing first, you are going to draw the directions of D. It is because of you want to know, you want to remind yourself the angle between the D and F. So the D and the push force over here going to be what? The work done here going to be FD cos 0 degree, because it's moving in the same direction. So it means that it's going to produce a positive energy, which means that the increase of energy. And how about frictional force? Okay, the frictional force over here going to be D. Yes, is going to be, wait, sorry, I'm going to, okay, it's going to be W equals to F D cos what? Cos 180 degrees. So it means that you are going to get negative energy, which means that it's going to be decrease of energy. Okay, so whatever the things is, you need to draw your D, and then you know what is the angle between D and your F for you to get your work done, whether it's going to be positive or negative. Okay. Okay, so in front of you, you can see that this person carries some groceries bag and then it's moved through some distance. So I want to ask you whether there is a work done. Yes, the answer is going to be there's no work done. The reason why is because when this person carries the grocery bag, is going to apply some push force, which is vertically, and then there's definitely we are going to have the mg over there. And the reason why there's no work done is because of the angle between D and FP is 90 degrees. So it means that when you put it inside your formula, FD cos here is going to be cos 90 degree. Okay, same goes as the push force and same goes as the mg. So this person basically doesn't do any work. Okay, and the things that you need to understand here is the unit for the work done. It can be a joule or it can be Newton meter. Okay. Okay, so example in front of you, you have a simple example only. Okay, basically in your exam questions, I'm not going to like resolve for you like this one. Okay, you need to resolve by yourself. And if the question asks you to find the net work done, okay, when you state the net work done, when you state the net work done, okay, it means that you need to find all the forces acting on that object, and then you need to find and then you need to plus or minus the work done by each forces acting on that object. Okay, so like the first question, the question state to you the work done by each force acting on the crane. Okay, so you are going to have push force over there with some angle, so definitely you need to resolve it into component, which is going to be FP sine 37, and this one going to be FP cos 37. Okay, and then you have the normal force, which is come from the floor, and then you are going to have the gravitational force, which is acting mostly on the object. Okay, so the question asks you to find the work done by each force. Okay, so work done by each force, so means that first thing first, we are going to do work done by Fn and mg. Okay, so work done by Fn, okay, normal force going to be Okay, so the directions of the D going to be in this direction. So the angle between the FN and the D will be F and D. Cos what? Yes, it's going to be cos 90 degrees. So the answer going to be 0 joule. Okay, same goes as work done by mg, which is the gravitational force. So it's going to be Fg here, D cos what? Cos 90 degree, because that's the angle between the mg and the D, the displacement. Then you are going to get also 0 joule. Okay, so how about Fp sine 37? Okay, work done by push force is going to be, you are going to write it in two parts, which is one is going to be the vertical part and another one going to be the horizontal part. So I'm going to find the work done by vertical part first, which is going to be Fp here, sine 37. Okay, and then you multiply with displacement, and don't forget your cos theta here is going to be, yes, it's going to be 90 degree also. Okay, so you are going to get 0 joule. Okay, and then the last one we have here is Fp cos 37 degree. So you are going to be have Fp, you can put it as y, this one you're going to put it Fp as. Okay, so it's going to be Fp cos 37 degree. Okay, D cos 0 degree. Okay, so your Fp here is 100 Newton cos 37, and your displacement, you move some distance of 340 meter, and then your cos here is cos 0 degree, because the directions of D and your Fp cos 37 in the same direction. And then you are going to get your answer here is 100 cos 37 times 40. So the answer is going to be 3.19 times 10 power of 3 joule, which means you are going to get positive energy, because which means that the increase of energy. Okay. Okay, so the next part is the question. Okay, you already find the work done by each forces, and the question asks you to find the net work done on the crate. So you need to plus all the things. If you have minus in your answer, then you put it as a minus over there. So now it's going to be, okay, so if I put it as the equations, it's going to be W net, oh sorry, this one good, W net, okay, equals to work done by normal force plus work done by gravitational force plus work done by push force in the y directions, and the work done by push force in the in the s direction. So you're going to get 0 plus 0 plus 0 plus 3.19 power of 4, power of 3 over there. Then you are going to get your answer is 3.19 power of 3 joule. Okay, that's how you find it. Okay, so you can actually find work done by each forces first, and then you find the work net work done, or you can actually just put it everything inside the W net and then get the answer. Okay, but it's compulsory for you to show why is going to be why the answer gets 0 joule. So you need, it's compulsory for you to show why the answer 0 joule. So you need to put it as a cos 90 degree. Okay, okay, so that work done by constant force. So you can actually see that in front of you there's a pictures over there where the moon are actually circulating the earth. Okay, and here is, you can see that moon doesn't do any work. The reason why is because of you move in these directions and your mg is in this direction. So what happened is the work done here is going to be, yes, it's going to be 0 joule. So that's the reason why the moon or the earth or any planet doesn't need any fuel. Okay, no work needed to be done against the force of gravity. Okay, okay, so okay, so we are move on with the kinetic energy. So basically work done is basically energy, which is the ability to do work. So the kinetic energy divided into mechanical energy and non-mechanical energy. So the mechanical energy is basically divided into two, which is one is going to be kinetic energy. Okay, another one going to be potential energy. Okay, so we are going to touch first the kinetic energy, and after that we are going for the potential energy. Okay, so here the things that you need to understand is the kinetic energy that we are going to discuss here is only for the translational kinetic energy, which means that it's moving forward. For something that is moving in the circular, which is moving in the circle or rotating, that one is we are not going to touch it. That's one going to be touched in the other chapter, which is the chapter focusing only for the rotational part. Okay, so here we are going for only translational part, which is moving forward. Okay, so there's a one theorem we call as the work energy theorem. So this formula, you need to make sure that you need to know how you get this kind of formula. What is the relationship between the work done and also the kinetic energy? So the formula itself is come from, okay, you can see that work done is basically force times distance cos theta. Okay, so example, if your F and your D is moving in the same direction, so I'm going to be the F and D. Okay, so F is basically comes from MAD. Okay, acceleration here, you are going to relate with the kinematics equations. We are going to have one equation stand for, which is V square. V is naught square plus 2A x minus S naught. Okay. Okay, so you put your A as your main subject, which is going to be A equals to V square minus V naught square over 2 S minus S naught. Here, your S naught here going to be, this is your S, and this S naught, this is your S, is moving through some displacement. So I'm going to change that into A equals to V square minus V naught square over 2D. And then you put the A here into this equation, then you are going to get work done equals to mv square minus V naught square over 2D over D. This one going to be cancelled out. Okay, then you rearrange everything, then you are going to get the formula is half mv square final minus half mv square initial. Okay, and this work done we call as the work done, net work done. Okay, this we call it as the work energy theorem. Okay, so means that if you find that in your questions there's some velocity over there and the question asks you to find the work done, so some students quite confused how to relate the work done with the kinetic energy, and basically you are going to use this formula. Okay, this formula, and please take note the net work done over there equals to the change of kinetic energy. Okay, so if we just put as half mv square, is going to be wrong, because the net work done basically is about the change of kinetic energy, which is final minus initial. Okay, so this is the things that I have mentioned before. So if your net work done is basically positive, it means that your energy, kinetic energy, going to be increases. If you get your net work done as a negative, it means that your kinetic energy going to be decreases. So this one may be the force acting is basically opposite, which means that maybe the frictional force is larger than other forces, so it's going to give your net work done as a negative, which means that your kinetic energy will be decreases. Okay, so here we have a hammer. Okay, so example, if the question asks you to explain what happened, which means that which one going to produce a negative work done, which one going to produce a positive work done, please do not mention that it's moving to the left or moving to the right, because work is considered as scalar. So the things happen here is you have a transfer of energy here. Okay, so what happening here is okay, the force acting on the nail, which is hammer to the nail, is going to be in these directions, and the nail to the hammer is going to be in these directions. But the question asks you which one going to produce negative work done and which one going to produce positive work done. So the things that you need to mention here is basically about the angle, the theta between D and also the force. So the work done on the nail going to be positive, going to be positive and the work done on the hammer going to be negative. So here we are going to have work done on the nail. Okay, I put it as a nail here, so it's going to be FD cos 0 because the D and the F in the same directions as D. Okay, so you are going to get positive energy, which is the increase of energy over there, and then work done on the hammer going to be FD because it's the F and the D is in the opposite direction, so it's going to get cos 180 degree, so you are going to get negative energy over here. So you have here there's a part of the energy going to be increased, there's a part energy going to be decreases. Okay, so this one you need to find the W net, and if the question asks you to find the velocity over there, so you can use W net equals to half mv final minus half mv initial. Okay, so this one question is practically very easy. Okay, this is like direct questions. So the question asks you to find the kinetic energy. So definitely you are going to use the formula of half. What is the kinetic energy? Which is half mv square only. Okay, so you're going to get 1/2, so 0.145 times with 25. Do not forget to square everything, so you are going to get 25 squared times 0.145 divided by 2, so you're going to get 45.3 joule. Okay, and the question to ask you to find what was the net work done. So here the things that you need to understand here when it comes to the net work done, it means that you have a change of kinetic energy. So as it started from rest, so you need to put it as a W net equals to half mv square final minus with a half mv square final. Okay, so as it started from rest, so the initial going to be 0, so you are going to get 1/2 0.145 25 squares, so you are going to get your answer is 45.3 joule. Okay, which is going to be equal to the net work done. Okay, so this one questions also particularly very easy. Okay, the question asks you to find the net work done, so it means that you will need to only use the formula of the W net equals to half mv square final minus with the half mv square initial. Okay, then you are going to get the answer, which is 2.5 power of 5 joule, and please do not forget to put the units. Okay, so let's move on with another types of mechanical energy, which is one of it is we call as a potential energy. So like before this, your kinetic energy is something that moving, so you move through some distance, so you are going to push some, so you have a displacement, so means that you are going to have some work done. But this one, when it comes to the gravitational potential energy, is always associated with the position, which means that you are going you have a change in terms of height, you have a change in terms of level, then you are going to produce a gravitational potential energy. Okay, so when you're raising a mass to the height, the work done by the external force, which is the work done by you pushing the object, going to be the gravitational potential energy. So basically what happened here is the name by itself, gravitational, so it means that W equals to FD cos theta. So the F here going to be mg and the D going to be height, so that's why you're going to get work done, or the potential is a mg h. Okay, so the height is the difference between the initial and final, so that's why you're going to get y minus y naught here. Okay, so when it comes to the potential energy, the things that you need to understand is about the change of level, the change of height. So here you have the force exerted by the hand and the force by the gravitational energy, gravitational force. So which one going to produce positive and which one going to produce negative? Okay, so here we are going to put that. Okay, you can actually just put it inside the formula as the W equals to F D cos theta. So the F over there going to be exited by the hand, which is upward, and the D going in the same direction, so you are going to get here as a 0. So you are going to get positive energy. Okay, so this is going to be done by hand. So how about work done by gravitational force? Is going to be Fmg. Okay, or I put it as a mg directly. Mg d cos what is going to be cos 180 degree. So means that the work done by gravitational force going to be negative joule. Okay, but this one depends on the questions. If example you release the box and then it's moving in the same direction as the mg, so means that it's going to have a gravitational potential energy where the angle going to be 0 degree. You are going to get positive gravitational potential energy over there. Okay, so the potential energy can become kinetic energy if the object is dropped. So basically what happened here is you are going to have some transform of energy from kinetic to potential, or from potential to kinetic. Okay, so example, if we have like one object, okay, at some height, okay, so the first thing that you need to understand is you need to choose your reference point. Okay, your reference point going to be the point where you are going to put your y as 0. You can choose any point. You can choose from the ground, okay, or you can choose from the ground. Okay, so example, if I choose this one, I choose the ground as my reference point, so I'm going to put my y here going to be 0. This is going to be a reference point. So this I have some potential energy over here, so means that here your kinetic energy going to be 0, means that the energy is fully converted into gravitational potential energy, which is 10 by u equals to mgy. And when the object is dropped and reach the ground, so what happened is you are going to have energy that been transformed from potential into kinetic energy. Okay, and here your potential here going to be 0, because this one I'm choose this part as my reference point. Okay, so it's up to you. You can choose any parts as your reference point, but you need to understand that the energy can be transformed. The energy cannot be destroyed, cannot be created, but can be transformed into other form of energy. So it means that it can be changed between kinetic and potential. Okay, so here if you your gravitational potential energy, where do you measure y from? Means that you are going to choose your reference point. It's up to you. You can choose your ground as your reference point, or you can choose at some height as your reference point, but you need to make sure that you are consistent. Okay, so example like this question, okay, this one is like basically direct questions. Okay, so you have so example like this one, okay, the question asks you to find what is the gravitational potential energy, which means that you are going to put it as u equals to mg y final minus y initial. Okay, at point 2 and 3 relative to point 1. So means that the question asks you to this question already put your reference point at point 1. This is going to be your reference point, and the question asks you to find the potential energy. So okay, so at point 2 and point 1, so point 1 to point 2 and point 1 to point 3. So point 1 to point 2, so here you're going to get u equals to m is 1000 and your g is 9.81. Please take note that don't put your g over there is negative 9.81, because g is basically scalar. The potential energy is scalar. You are going to put your direction at the y and y naught. Okay, you are not going to put your negative or positive at 9.1, just put number only. Okay, and your y is going to be 10 minus 0, so from here to from here, so you are going to get your answer as 9.81 times 4 joule. Okay, and that one is point 2. And how about point 3? Okay, so 1000 multiplied by 9.81, so point 3 is negative 15, is because this lower than your reference point, so minus with the 0 because your point 1 going to be your reference, so you are going to get negative 1.50 power of 5 joule. Okay, What is the change in the potential energy when the car goes from point 2 to point 3? For point 2 to point 3, okay, example, if I put what is the change in the potential energy? So I put my point 2 as my reference point, or you can put your point 3 as a reference point. So from point 2 to point 3, so I'm going to put as mg y3 minus y2 final minus initial, so it's going to be 1000 plus multiplied by 9.1. Y3 is going to be negative 25 because I put my reference point at point 2 minus 0. So I'm going to get my answer as 25 times 1 negative 2.45 power of 5 joule. Okay, which means that I have a decrease in energy. Okay. Okay, repeats part A and B, but take the reference point to be at the point 3. So what happened here is when you put that at the point 3 in your answer, okay, as your reference point, so now the point 3 going to be my new reference point. So for the question A, what is the potential energy at point 2 and point 3? So the point 3 going to be, the potential at the point 3 going to be 0 because that is my reference point. And for the point 2, okay, so the point 2 going to be mg y2 upon point 3 point 2, so y2 minus y3. This one going to be 0 because this is my reference point, so 1000 times 9.81, and it's going to be 25. So you are going to get your answer is 2.45 power of 5 joule. Okay. Okay, that's how you do it. Okay, so means that the way you decide your reference point going to need to be consistent. Okay, so choose reference point that make your life easier. Okay, like myself, I'm going to choose ground, mostly ground, as my reference point. Okay. Okay, so let's move on with the conservations of energy. Like I mentioned before, energy cannot be created, cannot be destroyed, but can change to other form of energy. So now we are going to change from potential to kinetic, or kinetic to potential. Okay, so we are going to use the concept of mechanical energy, which is denoted by E. Okay, before I proceed with the equations, I'm going to explain to you what does it mean by conservative and non-conservative force. So the conservative force here is basically the work done that's only depends on the initial and final only. So means that, example, if we have you moving from here, you're moving from here to here like this is your initial and this is your final, and then you move like this, but initial and final also same as the first one. The thing is, both are going to produce same work done. Okay, same work. Okay, it doesn't depends on the path taken here, it depends only on the final and initial only. So that's what it means by conservative force. So conservative force, we have only 3 in this world, which means that we have gravitational potential energy, okay, we have elastic, and then we have electric. Okay, only these 3 we consider as a conservative force. Other than that, non-conservative force, which means that it depends on the initial and final. So it depends on the path taken, like friction, push, pull. That one we consider as a non-conservative force, which means that you need to take note about the path taken. You don't consider only about the initial and final, but you need to take into account the path taken. Okay, other than that, other than these 3, we call as a non-conservative force. Okay, so example like friction. Friction is basically the most common non-conservative force, which means that you need to consider about the path taken. So like this one and this one, which one going to produce a larger work done by frictional force? Definitely going to be, yes, this one. Okay, because the path taken is larger. That's the reason why you are going to see that your work done by frictional force or work done by pull force going to be larger than this one. Okay, because we consider about the path taken, and that's we consider as a, and that's when we categorize as a non-conservative force. Okay, Like I mentioned before, other than these three, all is a non-conservative force. Okay, so like gravitational, we consider only final and initial. So if you, example, moving like this or you moving like this, basically these two are going to produce same gravitational potential energy because it can be categorized as conservative force. Okay, so let's start with the equations of mechanical energy. So like I mentioned before, we basically calculate the energy that we conserve. It means that the energy cannot be created, cannot be destroyed, but can change to other form of energy. So now we are going to discuss about the energy that be changed from kinetic to potential or potential to kinetic. Okay, so if there's no changes in terms of energy, so means that your mechanical energy here going to be zero. Okay, because there's no change in terms of energy. Example, okay, from rest. Okay, so from rest we consider as a 0 joule. Okay, and then you run, so you gain 50 joule from the kinetic energy. So because of the mechanical energy, which means that we conserve 50 joule over there, not going to be constant. It means that there's something energy that going to be to make this 50 joule back to zero. So example, if you're running and then you jump, okay, and then you jump, what happens is you are going to change from kinetic to potential. So means that the 50 joule from kinetic are going to be transformed into potential energy, which is also 50 joule. So there's no changes because 50 joule is 100% transferred. That's why your mechanical going to be zero. Okay, it's going to be zero here. Okay, so so we put it as a mechanical energy as a K plus U, which is the combinations of kinetic and potential. So in for the kinetic energy, you can say that you have half mv final minus half mv initial. Okay, and the potential energy, you are going to have the mg y final minus mg y initial. Okay, so because we consider about the energy that conserve between and then be transferred from kinetic to potential, so means that when you rearrange the equations, you are going to get half mv initial square plus mgy equals to half mv final square plus with the mgy final. Okay, mgy final. Okay, so this is the equations which is we consider only for the conservative force. But if the example you have a equations that you need to consider about non-conservative force, which is one example is going to be friction, you are going to change a little bit the equations where the equation is going to be work done by frictional force. Okay, as I mentioned before, the frictions, okay, example you have like pull over here and then you have a frictions always like oppose the motions. Okay, for this condition, oppose the motion, so means that work done by frictional force going to be Fr going to be force times distance cos 180 degree. So it's going to produce a negative work done. So when it comes to the equation here, where is the part that you need to put the work done by frictional force, which is work done by conservative force? Okay, you need to understand that we only consider about energy that conserve, which means that your E here going to be 0. So you need to put your equation as K plus U plus work done by frictional force, which means they're going to be 0 here. Okay, this is only general equations. Okay, but the things here, as you can see that the original equation, which means that when I put it like here, okay, so you separate into initial and final. So I'm going to put it as a half mv square initial plus with the mgy plus with the work done by frictional force equals to half mv final square plus mgy final. Okay, so here you can see that I put it positive here because I didn't put it with the cos theta yet. So if you put your work done by frictional force at the initial part, the things that you need to understand is going to be negative. The reason why is because of half mvi square plus mgy yi plus work done is, wait, it's going to get force FFR time distance cos what? Cos 180 degree, because it's opposed to motions. So half mv final square plus mg y final. So means that here you are going to have a negative work done by frictional force. Okay, you can just directly put the negative over there, but please make sure that you show the cos 180 degree, but please do not make it redundant. Okay, if you put cos 180 degree, you put plus here first. Okay, and then you know that by yourself cos 180 degree is negative. Okay, if you can actually put your work done by frictional force at the final part, so means that you just transfer the equation to the other side. So you are going to get your formula as a half mvi squared plus mg yi half mv final square plus mg y final plus work done by frictional force. Okay, but please take note, at this part please do not put cos 180 degree. You don't have to, because the original equation is at the initial part here. Okay, so when you transfer to the other side, the negative going to be a positive. Okay, so you just put as a FFRD only. Okay, and you know by yourself it's already cos 180 degree from the initial part. Okay, and that's how you use the equations. If the questions state the frictional force, so you need to consider about this part. But please take note, friction is considered as a non-conservative force, which means that you need to take into account the path taken. Okay, the path taken. Okay, so that's how you use the formula. Okay, so this one, the principle of conservation of energy, if only conservative forces are doing work, the total mechanical energy of the system neither increase nor decrease in any process, is always stay constant, is always conserved. Okay, if only conservative force, it means that you are going to change 100% from kinetic from potential, or 100% potential from the kinetic. Okay, so this one, in the image on the left, the total mechanical energy of any point is going to be the difference, the change between the kinetic and potential. So make sure that you choose your reference point. Example here, they choose reference point at the ground, so your y final going to be 0 over there. So you are going to have your potential here. Okay, so you are going to have your potential here. Okay, and then your half mv square here going to be 0, and then it's move with some height, so means that from potential 100% going to change into kinetic energy. Okay, but whatever things happen is your mechanical energy always be constant. Okay, 50 joule you gain means that 50 joule going to be lost, or 50 joule you gain from the kinetic going to be changed into 50 joule of potential energy. Okay, so example, this is one of the questions that you might encounter in your exam, but this one is pretty easy. Okay, so the question asks you to find the speed when it has fallen to 1 meter above the ground. So you are going to use the formula, which is consists of kinetic and potential. So you are going to have half mv square initial plus mgy initial equals to half mv square final plus mg y final. Okay, it's better for you to always write your equations and then you just put a 0 for which part the hand need to be 0, like at rest. Okay, example. Okay, so now example, if I put my reference point at the ground, so the going to be the final here going to be 0, so then the initial for the kinetic going to be 0, so means that you are going to end up with the mg y initial equals to half mv final square. Okay, so the m here going to be cancelled. Okay, so vf going to be 9.81, so the highest is 2. Okay, because the question asks you to have fallen to 1 meter above the ground, so 3 minus 1 is going to be 2, so square root everything, then you are going to get 4 times 9.1, square everything, you are going to get 6.26 meter per second. Okay, and what is the rock speed just before it hits the ground? So it means that the same formula, so I'm going to put as a 2 times 9.81 is 3, so you are going to get 7.67 meter per second. Okay, As easy as that. Okay, so I'm going to explain to you like this one part where these questions always be asked in your exam. So example, you have like a cliff like that. Okay, example, and this cliff have the same height as this one. Okay, so what happens is when you have a car over there. Okay, so here definitely we are going to have a potential energy. Okay, so when the car reach at this point where I assume this is my reference point, so the potential energy from here are fully converted into here as a kinetic energy. But once it reach to this part, okay, the car over there not going to stop. The reason is because the kinetic energy over here is not fully convert into potential energy. Okay, because example, if you have like 50 joule here, okay, 50 joule from this height, so what happened is this is like maybe like around 25 joule, so means that the kinetic energy just convert into potential energies only for 25 joules. So the 25 joule going to be kinetic, 25 joule going to be potential energy at this part. That's the reason why the car are going to still moving and not going to stop. It's going to stop if example the 50 joule over here is fully convert back into potential energy. So means that here you are example like this. Okay, so means that the car going to stop here because the kinetic energy from here, which is kinetic energy already gained 50 joule, is going to fully convert into the potential energy as 50 joules. So what happened here is the car going to be stopped at the same level. Okay, so means that here you need to be extra careful with this kind of questions. It's going to be like pretty easy, but you are might going to get confused when it comes to which part you are going to put zero, whether it's kinetic initial or kinetic final or potential initial or potential final. Okay, so be extra careful and please make sure that you choose your reference point carefully. Okay, this one is like very easy. Okay, so example, you have the height of the hill is 40 meter, and the speed and the question asks you to find the speed of the roller coaster at the bottom of the hill. So you know that at this part you have a potential energy and you are going to fully convert into this part as a kinetic energy. So you are going to use the formula. Okay, make sure that you always write full formula before you proceed with the calculations. So half mv initial plus mgy initial equals to half mv final square plus mgy final. So here the roller coaster is start from rest, so definitely we are going to put initial kinetic as a 0, and that's fully convert at the bottom as a kinetic energy. So your final potential is going to be 0. Okay, so you are going to end up with mgy initial half mv final square. So m going to be cancelled here. So you are going to get your v final as 28 meter per second. At what height you will have half the speed? Take y not y at 0 at the bottom of the hill. So the question asks you to find at what height e will have half the speed. So means that the question asks you to find potential, which means that you need to use potential energy with the half of the speed. Okay, so half of the speed is going to be 14 meter per second. So the 14 meter per second is going to produce some work done with this energy going to reach you at a certain level only. Okay, so I'm going to put it as okay, I'm choose at the bottom of the hill as my reference point. So half mv initial plus mg y equals to half mv final plus mg y final. Okay, so the bottom of the hill going to be a 0. Okay, and then okay, because the question asks you to find at what height, so it means that this one going to be 0. Okay, I'm just directly use that my it means that at the bottom going to be my initial, which is half of the speed, half of 2, so m going to be cancelled here. So half of it is 14 square, so I'm going to get g here is 9.81 with the y final, which I didn't know. So sorry, so this one square divided by 2 divided by 9.81. So you are going to get your height going to be 10 meter, which is this is 10 meter at this part. Okay, sorry, this is 10 meter at this part, but the question asks you to find at what height from the bottom. So means that your height is 40 meter, you are going to reach at y final at 10 meter. So it means that you need to put 40 minus 10. So the point that you are going to reach with the half of the speed going to be 30 meter from the bottom. Okay. Okay, so in front of you, we are going to have animations about how the energy going to be transferred from kinetic to potential. Okay, so basically what happened here is this is kinetic, this is potential, this is work done by frictional force and total mechanical energy. So the things is, so it means that it's moving downward, okay, and then means that the potential energy are going to fully convert into kinetic energy, which you can see from here. And then the kinetic energy are going to be fully transformed into work done by frictional force, because you have unpaired snow, which is friction. But whatever things happen is your total mechanical energy always be zero. Means that if there's something to increase, definitely there are going to be something that decrease the energy, to make sure that your total mechanical energy always be zero. Okay, so this is one of the conceptual questions. Okay, so two water slides at the pool are shaped differently but start at the same height. Okay, so two riders, Paul and Kathleen, start from rest at the same time on different slide. Which rider, Paul or Kathleen, is traveling faster at the bottom? Okay, the answer going to be both. Going to travel faster at the bottom, because as you can see that even though the shape of the pool is different, but it start and end at the same point. So what happened is the potential energy are going to fully convert into kinetic energy with the same energy, with the same amount of energy. So that's the reason why Paul and Kathleen are going to have the same, are going to travel faster at the bottom. Okay, which rider make it to the bottom first? Okay, here the answer going to be Kathleen. The reason why the answer is Kathleen is because of, you can see that from the shape itself. Okay, Kathleen are going to change the potential to kinetic earlier than Paul. Okay, you can see the shape here. Okay, because this is the potential, you have a potential here. Okay, and then because the shape of the pool for the Kathleen, it makes the potential going to change into kinetic energy earlier, which means that the Kathleen are going to move faster than the Paul. Paul going to have like potential, and then is going to change into kinetic, but it's going to be later than the Kathleen. Okay, so I already explained everything here, so it means that you can actually find the answer, or the fully conceptual answer for this one in this part. Okay, so example here, we have the questions that estimate the kinetic energy and the speed required for 70 kilogram pole vaulter to just pass over a bar 5 meter high. Assume the vaulter center of mass is initially 0.90 meter off the ground and reach its maximum height at the level of the bar itself. So the question asks you to find the kinetic energy, which is the initial kinetic energy for this person to reach 5 meter height. Okay, so means that when it comes to this, okay, so we have, definitely you need to write the equation first. Half mv square plus mg yi equals to half mv final square plus mg y final. So the question asks you to find the initial kinetic initial speed. Okay, so it means that this one going to be 0, and then when it reach at the maximum height, so the velocity here going to be 0. So you are going to end up with half mv square plus mg y final. So m can be cancelled out. Okay, so you're going to get 1 over 2 vi square, so 9.81. So because the center of mass is initially 0.90 from the ground, so you're going to get 4.10. So you are going to get your answer as 4.10 times 9.81 times 2. So the answer going to be 8.97 meter per second. Okay, so this is going to be the answer. Okay, very easy. Okay, so here is one of the complex questions because we have a friction over here. Even though I prepare for you already the answer at the back, but I'm going to show you my method to solve this kind of questions. Okay, please take note, if the question state you need to use the energy method, please make sure that you use the energy method. If you use the Newton's law method and then you get the answer which is correct, however, you are going to get marks only at the final answer but not on the working step because the questions already state use energy method. If example the question didn't state any method, you can use energy or Newton's law method. Okay, so I'm going to solve this using energy method. Okay, and I'm going to show you how to use the Newton's law method. Okay, so first thing first, this question you need to draw everything need to draw when it comes to the physics. Okay, so moving with the speed of 12.9 as he start his descent from a level plateau at 123 meter height to the ground below. So it's going to be like this, like this, like this. Okay, so this is going to be 123 meter, 123 meter. Okay, and this this person start and basically moving here 12.9 meter per second, which means that you can say that at this part is going to have a potential and kinetic. Okay, the slope has angle of 14.1 degree and the coefficient of friction, so there's going to be a frictions over here, which is the frictions, the coefficient is going to be 0.121. Okay, and then when you reach the bottom, you continue to coast to the stop, and then you are going to still have a frictions over here, which is the frictions here going to be 0.623. And the question asks you to find how far, which means that is going to ask you distance, the displacement. Okay, the D over there. So first thing first, when it comes to the energy method, okay, definitely I'm going to find the speed after you reach the bottom. Okay, so I'm going to use the formula of half mvi square plus mgy final equals to, okay, because you have a frictions over there, I'm going to put my work done by frictional force maybe at the initial part. You can put at the final part, but please make sure that when you put the final part it need to be positive. Okay, so this one going to be plus, okay, work done by frictional force. I'm going to show you step by step. Half mv final square plus mgy final. Okay, so at the early part there's going to have a potential and kinetic, so at the bottom is going to fully convert into kinetic, so the final going to be 0 over here. So you're going to get the formula here, half mvi square plus mg final plus this word done by frictional force, which is ffr d cos 180 degree equals to half mv final square. So half mvi square plus mgy final. Okay, because it's going to be put at here, so means that you need to be extra careful for this one. You have normal force. It's better for you to draw. You have mg cos theta. You're going to have this one as the mg sin theta. So this one going to be ffr. Okay, the reason why you need to draw is because friction considered as a non-conservative force, which means that you need to take note into the path taken. So you need to find the inclined plane. What is the D for that one? So here I'm going to find it first. Okay, I'm going to put like this. So I'm going to use sin theta. Okay, my sin theta as the opposite over hypotenuse, so the sine going to be 14.1. Okay, and the opposite I didn't know. No, opposite is 1, 2, 3 hypotenuse. Okay, so I'm going to get the hypotenuse first. So sine 14.1 time by answer. So I'm going to, so the inclined plane is 45.9 meter. Okay. Okay. So here is going to be okay plus no, I'm going to put it as negative because directly negative mu mg cos theta d half mv finite square, because you need to understand that ffr equals to what? Equals to mu fn, and the fn here is mu mg cos theta. Okay, so you can cancel m here, so you are going to get 1 over 2 12.9 square plus 9.81. Y final is 123 minus mu is 0.121. 9.81 cos 14.1. D is 504.9 equals to 1 over 2 V final square. So you need to get the V final first. Okay. Okay, the answer is 37.64 meter per second, which is going to be at this bottom, the velocity at this bottom. Okay, and then you need to find how far, which means that the only thing there is going to be kinetic energy and also work done. Okay, so here work done by frictional force. Okay, because potential energy already be 0 over there, because I put my reference point at the bottom, so it's going to be initial and final, because it's going to stop at the end. Or you can actually use work energy theorem, okay, which means I'm going to put it as a half mv final square minus half mv initial square equals to work done by frictional force. Okay, that work energy theorem. Okay, so because it's going to stop, so final going to be 0. So this one negative 1 over 2 mvi square equals to, okay, because at the bottom you only have Fn mg and the friction, so it's going to be mu negative I put it here, mu mg d cos 180 degree, because the friction oppose the directions, oppose the d. Okay, so here you're going to get to cancel, you're going to cancel m here, so you're going to get half 37.64 square equals to mu is 0.623 9.81. Then you are going to get d there, and the answer is 115.9 meter. Okay, so this is how you do it using the energy method. Okay, so you need to do it one by one, then you can actually see that. Okay. Okay, so I'm going to show you also how to solve this question using Newton's law method. Okay. Okay, let's solve the same questions using Newton's law method. Okay, so I'm going to draw it first. Okay, so when it comes to the Newton's law method, the things that you need to understand is you need to find the acceleration first. So example, you have like the object here, so you need to draw all the forces, complete FBD, the mg sine theta, and this one going to be mg cos theta. Then you have a friction. So you are going to find the acceleration first for me to find the v here using the kinematics. Mostly for the Newton's law, you are going to combine with the kinematics. Okay, so the equation here going to be for the horizontal part going to be mg sine theta minus ffr equals to me. Okay, so the mg sine theta minus with the mu mg cos theta equals to me. Okay, so m can be cancelled, so you are going to find it 9.81 sine 14.1 minus mu is 0.121. 9.81 cos 14.1 e. So find the a first. acceleration here, you're going to get 1.24 meter per second square. Once you find the acceleration, the things that you need to find here is v, which you're going to use kinematics. Okay, so I'm going to use the formula, which is v square v naught square. Okay, so I'm going to put it here. V square equals to v naught square plus 2ax minus x naught. So I need to find the v final here. My initial is going to be 12.9 square plus my acceleration is 1.24, and my inclined plane that I calculated before is 504.9. So I'm going to get my v final as 37.67 meter per second, my v final. Okay, and then once I find the v, I need to find the how far, which means that the box is going to be like here. Draw the fully FBD mg, and then the FFR are going to be in that direction. So means that my formula going to be negative FFR equals to m e. Okay, once I need to find the acceleration first, then I'm going to find the d. Okay, so negative mu mg d umg equals to me. So m can be cancelled out, so you are going to get a equals to 9.81 times with the mu is 0.623, negative over there. Okay, so you are going to get negative 6.11 meter per second square. Okay, once you find the acceleration at the bottom, the next part is you are going to use the kinematics again to find the d. Okay, so I'm going to use the formula, which is the same as the earlier one. V square v naught square plus 2a x minus x naught. Okay, so this one going to be 0 because it's going to stop, so final going to be 0. So okay, so 37.67 square plus 2 negative 6.11 x. So I'm going to find x, which is how far. So the answer going to be 115.7 meter. Okay, so this is the Newton's law method. So if the question didn't state any kind of method, you can use like Newton's law or energy. But if the question specifically state you need to use Newton's law or specifically state needs to energy method, please follow the instruction of the questions. Okay, so this is like what another method that you can actually use. Basically it's the same thing like the one I mentioned before, like the one I've showed you before. Okay, so please do it, and if you feel that you are not confident enough with your method, you can ask me. Okay, so the last part is going to be power. Okay, so what happened is power is basically the rate of energy transform. So it means that how much that you transform from one type of energy into another type of energy. So the power is basically the formula going to be power is work done over time. So you have instantaneous power, which is power at that particular point. Okay, so you are going to get the differentiate of dw over dt. Okay, so the power unit is also, we can put it as a joule per second or watt. And as you can see that another formula that you need when it comes to the power, you can actually use power equals to work done over time. So work done is force times distance over time. So distance over time is what? Yes, it's going to be velocity. So you can use the formula, which is force times velocity, which is another formula for power. Okay, so you can state also power can be described as energy transform. How much energy been transformed from one type to another type. And then in the British system, the basic unit for power is foot-pound per second, but we can mostly call it as a horsepower. Okay, but this one, the conversion unit for this one, you don't have to memorize. If example, if I ask you in horsepower, I'm going to give it to you the conversion unit. Okay, so let's answer this question, which is, this one is quite easy. Okay, a 60-kilogram jogger runs up a long flight of stairs in 4 seconds. The vertical height of the stair is 4.5 meter. Estimate the jogger's power output in watts and horsepower. Okay, so I just give it to you the answer in watts. Okay, so 4.5 meters. So you need to find the energy first, which means that the energy here going to be potential energy. So I'm going to be the put as a power equals to work done over time, which is going to be mgh over time. So 60 times 9.81 times height is 4.5 meter over time, which is time is 4 seconds. So you are going to get your power as 662 watt. Okay, and the question asks you in horsepower, so means that 662 watts times to 1 horsepower equal to 746 watts. So the answer going to be 0.89 horsepower. Okay, so how much energy did it required? Okay, so you're just going to use this one, which is E equals to mgh, U equals to mgh. So you are going to get the answer is 2600 joule. Okay, as easy as that. Okay, so this one already I show you. Power is also needed for acceleration and for moving against the retarding force of frictions. And the power can also be written as FV. Okay, I already show you how to get this formula. Yeah. Okay, so this is like another example of the questions which relate with the power. So the question asks you to find the power to climb a hills at a steady 80 km per hour. So definitely when it comes to 80 km per hour, you need to change first into meter per second. Okay, so we means that we need to find the push force for the car to accelerate. So the equation is going to be here is, okay, the retarding force is opposite side. So you are going to get the push force, which means that equals to mg sine theta plus with the retarding force. Okay, because in the same directions. Okay, so you are going to get here is F equals to 1400 times 9.81 sine 10 degree plus retarding force already mentioned here, which is 700 Newton. So you are going to get it which is 3600 Newton. Okay, so the question asks you to find power, right? So power equals to force times velocity. So velocity 80 km per hour, you need to change first into meter per second, which I'm going to get 80 km per hour is 22 meter per second. So 3100 times 22. So you are going to get your answer is 6.80. The question 6.80 times 4 watt. Okay, or in horsepower, you just change into horsepower, then you are going to get your horsepower as 91 horsepower. Okay, so question for B, the car accelerate along a level road. Okay, so it means that along the level road, so you don't have to do like inclined plane over there, level road, from 90 to 110 kilometer per hour in 6 seconds. So we need to find like the upthrust force, example upthrust force first. Okay, the force that pushed the car to make sure that it's going to be accelerate. So in the level road, so means that you need to find the acceleration first. So okay, 90 and 110 you need to change into meter per second first. So I'm going to find the acceleration, which is going to be here is final minus initial divided by time. So 30.6 minus 25.0 divided by time, which is 6 seconds. Then you are going to get your acceleration as 0.93 meter per second square. Okay, once you find the acceleration, then you need to find a force, which is like the upthrust force. Okay, because it's level road. So you are going to have something that definitely accelerate you. Then you are going to have the retarding force. So you need to find the net force, which is ma. So this one going to be fp minus ffr, right? So fp minus ffr equals to ma. You want to find something that upthrust, which is going to push you to accelerate. So fp here is ma plus fr. Sorry, this one is fr, retarding force. So 1400 multiplied with the acceleration here plus with the retarding force, you are going to get 2000 Newton. Okay, once you find the force, the things that you need to do is power. Okay, So power equals to force times velocity. So 2000 multiply with which is 30.6. So you are going to get 2000 times 30.6, 6.12 times 4 watt. Okay, the reason why I'm using 30.6, which is 110 kilometer per hour, because that is the velocity that makes sure that your car can pass through another car. Okay, that's why you are going to use the final one, which is 110 kilometer per hour instead of 90 kilometer per hour. Okay, then you change this one into horsepower, so you are going to get that as a 82 horsepower. Okay, so I think that's all for now. Okay, so hopefully this one going to help you a lot in terms of understanding. And if you didn't understand, or is there something that you feel confused, you can ask me. Okay, so thank you very much, and I'm going to see you again for the next chapter. So assalamualaikum and goodbye.